Welcome to our session on probability. In this session, we're going to understand occurrences that happen by chance. So probability is simply the chance that an event will occur. Probability ranges from probability 1, 2, 3, 4, up to 5. And so I'm going to start with what are called axioms of probability. These are the formulas that surround probability characteristics. So we're going to start with the first one, which is called A union B. To unite is to add. A union B means the probability of A plus the probability of B minus the intersection of A and B. A intersection B, we're just exchanging this formula here. This guy comes this side and this guy goes the other side. So we're going to have A plus B minus the probability of A union B. Then the probability of an entity A is simply given by the number of entities of A over the sum total of events. So if you have 3 girls and 4 boys, it means the probability of a girl is 3 out of 7, the sum total. The probability of a boy is 4 out of 7, the sum total. If we're asking for the probability of B, it also follows that the probability of B is the number of events in B over the sum total. If we have 3 oranges and 7 bananas, we have total fruits that are 10. The probability of picking an orange is 3 out of 10, which is 30%. And the probability of picking a banana is 7 out of 10, which is 70%. The complement is simply the probability of not. So the probability of not picking a banana is therefore 1 minus the probability of picking the banana. I want to be as practical as possible. We have a basket here. We have how many bananas? We have 4 bananas. And how many oranges? We have 1, 2, 3, 4, 5, 6 oranges. If you shuffle this basket, the probability of picking an orange is the number of oranges that we have in here, which is how many? 1, 2, 3, 4, 5, 6, over the probability of the total number of fruits that we have. These fruits in total are 10. So we're gonna have 6 out of 10, which is 0.6. So the probability of picking an orange is 60%. Therefore, the probability of not picking an orange is simply O complement. It means not picking an orange, simply 1 minus the probability of picking an orange. So in this case, the probability of not picking an orange is 40%, which is 0.6 from 1, which is 0.4. I want you to enjoy probability because this is the toughest and yet the most practical. So can somebody tell me what's the probability of picking a banana? The number of what? Bananas over the total events. The total number of events, which are the fruits. So we have how many bananas? 1, 2, 3, 4. So 4 out of the total number of fruits that we have, which is what? 10. So we're gonna get 0.4. So what's the probability of not picking a banana? It is B complement, which is 1 minus 0.4. Ultimately, you're going to get 0.6. At this point, any questions? Are we together?
Yes.
Yes, it's clear.
All right. Now, we also have what is called conditional probability. Conditional probability is given by A given B is equal to what? The probability of B goes down there. Udi pancha pancha po. Then you intersect the two letters. Probability of A intersection B. That is called Bayes' theorem. This is called Bayes' theorem. Okay. So if I were to swap them, B given A, which probability goes down? The A goes down here. The two letters. So of course, you can start B intersection A or A intersection B. It's okay. Of course, we love to start with letters that come first in the alphabet. Are we together at this point?
Yes.
So, ngatwachita multiply hapa. We cross multiply. Here there's a 1. So we're going to have the probability of A intersection B is equal to probability of A given B times what? The probability of B. When these two are kissing, it means there is an intersection. So B given A, I need to multiply it by the base A itself to give me an intersection. So times the probability of what? The A. We're going to get the intersection of A intersection B. So if you're given a contingency table like this one here, A, B, X, and Y, 1, 6, 2, and 1. What is the probability of A? The first thing you need to do, you get the totals. The total for A is 7. The total for X is 3. Here we have a total of 10. So actually B, the total for B is 3. The total for Y is what? 7. So after getting the total for each of them, we are going to now calculate the probability of each of them. So what's the probability of A? Is the number that A has over the total events that A has. So A, the total for A is what? 7. So here we put a 7. Over the total events, 10. So here we're going to get 0.7. But where could it be? What's the probability of B? We go to the total for B, we have a 3 over the total of totals, which is 10. Here we get 0.3. Can somebody tell me what is the probability of X? S naught, where's S naught? What's the probability of B, NESA and S naught? And what is the probability of Y?
Okay, so the probability of X will be 3 over 10, which will be 0.3.
0.3.
Yeah.
NESTA, S naught, Y, what's the probability of Y?
7 over 10.
7 over 10, which is 0.7. This is what you are supposed to do. It's as easy as this. You laugh how I'll show you the previous test the way it came. This is coming in test 1. He loves it. The contingency tables. All right. So ask for questions.
You are breaking. We didn't get what you're saying.
Can you hear me? Am I clear?
Now we
Now
can.
we can get you.
All right. Okay. So I'm told some people are failing to join in because there's a passcode. There's no passcode. Let me resend it. All right. So we're gonna now look at what we call the intersection of A and B. Intersection is where they meet. So A and B, where are they meeting? You just draw a plus. A and B, they're meeting at what? They're meeting at 1. So you put it 1 over 10. So this is 0.10. Okay. Can somebody tell me X intersection Y? What is the probability of X intersection Y?
One over 10.
1/10.
They're meeting at 1. 1 over 10, which is 0.1. Okay. Any questions this far?
No.
All right. How about, can somebody tell me B intersection X? What is B intersection X?
It will be 2 over 10.
Is 2 over 10, which is 0.2.
2.
At this point, are we together? Now, I had asked you that the most faithful formula in probability is the union set formula. A union B. Who can remember the formula for A union B?
Probability of A plus probability of B minus probability
of
A intersection B.
All right. So did we find the probability of A? Yes, we found the probability of A as 0.7. Probability of B, 0.3. And the intersection, 0.1. So 0.7 plus 0.3, 0.7 plus 0.3 minus 0.1. What do we get as our answer? 0.9. Okay, can somebody tell me how do we find the probability of X union Y? In the same format, how do we find X union Y?
Probability of X
Probability of X,
plus probability of Y
probability of Y,
minus probability of X intersection Y.
as probability of X intersection Y. Great. So the probability of X we had was what?
0.3
and 0.7, and the intersection is 0.1. Coincidentally, they are the same. Not always that they always have to be the same, but that's what we are having there. Now, in probability, which word means is the same as and which word is the same as or? And is the same as intersection or multiplying, or is the same as union and addition.
And addition.
Are we together?
Yes.
So this is how easy probability is. My people perished because of lack of knowledge. So I will now take you through the test one that they had last year. So please don't embarrass me. What I've just taught you is on record. Let us now look at a question based on test one of last year, the distance one. So we're going to do everything that I have done. I will send the question paper on the group. Then we apply. This is the basic probability that we have done. So we're looking at the distance test, test one. So don't get confused. I don't want to leave anyone behind. This is the residential test. Okay, I'm not getting any questions from anywhere else. Okay, but from what is already I've sent you the pamphlet on the group and the question on the sedan. This one here. So this was for the part-time, not for the distance. The following data shows the number of cars of various types of at local dealership. So we've been given a sedan 2409, new 2415, used 9, and what? And 12. So we've been asked to find the probability that it's a new car. So with this data, let me just summarize it on the worksheet. So just memorize or screenshot it. So we have what? We have the following data. Here we had sedan and SUV, and we had new and used. So we have 2415, 912. Nine and 12. And we have the questions as follows. One, being asked to find the following probabilities. Determine the probability that the randomly selected car is new. Determine the probability that, okay, before I go there, let me explain the other thing that I haven't explained here. There's also what is called conditional probability. So when I'm dealing with conditional probability, you'll be given a question to find what's the probability of A given B. So A given B, what you do, somebody to expand A given B for me. What is A given B?
Will equal to
intersection.
B goes down there. Then here we have A intersection what?
B.
B, good. So we have our A intersection B here as 0.1. You put it here. And we have the probability of B was what? 3 out of 10, which is 0.3. So when you divide this, we're going to get 0.33. But I'll teach you a shortcut. A given B, you go where they meet. A and B, where do they meet? They meet at 1. You put 1. But the total for the bottom guy, what's the total for the bottom guy? 3. So we're going to have 1 over 3, which is 0. What? 33. If it was reciprocated, B given A, where they meet, where do they meet? They still meet at 1. But this time the total for the bottom guy, what's the total for A?
7.
7. All right. So give me X given Y and Y given X in that order. What is the probability of X given Y? And what's the probability of Y given X? So I'll start with Goret, Chewe, and Delphine. Then we are going to have Gloria, Gil, and Kapola in that order. X given Y, the first team. What do I put on top here? The formula, first of all, is given by what? X given Y, what's the formula?
I told
X intersection Y over what?
over probability of y.
Y. And here, what are we going to have? Where they meet?
1
1. And the total for what?
y.
Which is what?
7.
7. Good.
7.
You can leave it in decimal places. Okay. Which is 0 point something. How about Y given X? When you expand it, it's X.
Y or intersection, okay, over probability of X.
And they still meet where?
1,
And the total for X is what?
3.
The total for X is 3. Now here's an exam question. We're given a sedan, SUV, it was a new and a used vehicle. So what's the first thing you do? Stewart,
Use
Moses, and
photos.
Kamba. What's the first thing you do? And Kalonji. What do you do?
Sorry, I didn't get your question.
The first thing, what do you do when you're given a contingency table? You get the totals. What total do we have here?
33,
33. What do we have here?
27,
27. What do we have here?
39,
39. What do we have here?
21,
21. The grand total?
60.
60. All right. Determine the probability that a randomly selected car is new. What are they asking for?
Probability of new, the new.
Good, the probability of new. So how do we find the probability of new?
The total for new over the aggregate total.
Over total.
The total for new, which is that 9 over the grand total, the aggregate total, which is 60. What do we get?
0.65.
0.65. All right. The BIDs, those that have joined today, we call you BID because you're brought in that we don't know what you've learned. Okay. Determine the probability that a randomly selected car is a sedan. BIDs. What are we looking for?
Probability of the sedan.
Probability of a sedan, correct. Writing her name now. Of a sedan. So how do you find the probability of a sedan?
33 over 60.
The total for the sedan, which is the 3 over 60, which is what?
Yeah.
Zero point what?
0.55.
0.55. All right. The gentleman now. Determine the probability that a randomly selected car is a new sedan. This means we're looking at the probability of new and sedan. New sedan is one word, the same as new and sedan. The word and means what?
Intersection.
Multiplication or
Excellent.
intersection.
Intersection. So N intersection S. So what are we looking at?
Probability of 24.
We're looking at where new and sedan are meeting,
Mhm.
and then over sedan, over the total for and down there 33.
All right. Are you sure? You started well, but you messed it up.
Just a question.
No, over the total.
The question says, determine the probability that a randomly selected car is a sedan. So why are we bringing in the new?
We are at part 3, by the way. We are done with the sedan here.
Oh, over 60.
It's a new sedan. So where they meet, 24 over 60. Excellent. What do we get?
0.4.
0.4. All right. Then lastly, determine the probability that a randomly selected car is either a used or an SUV. What are they asking for?
Union or addition.
Okay, I want you to try that one. Or means what? Union. Excellent. Is that Kalonje? Who answered that?
Yes.
Yeah. Kalonje, you're doing very fine. I'm impressed. This is what I need. All right. So union sedan. So who can expand this formula? So this is probability of what?
Used.
Plus
Used.
probability of what?
Probability then
Minus
minus
Probability of use in
of
intersection.
sedan.
Excellent. So the used, what's the probability of the used?
Is 21 over 60.
And 1 over 60. Sedan?
$33 over
60.
33 over 60. And the intersection of used and sedan?
24 over 60.
over 60.
Used and sedan.
Used and sedan.
No.
9 over 6.
9 over 6.
So minus 9 over 60. So if the denominator is the same, we just work on the numerators. So this plus that minus that. What are you getting?
$45.
Over 60.
And the final answer in decimal will be what?
0.75.
0.75. Okay. 0.75. So I'm done with the contingency table. Your homework on this table will be question number 25 of my revision kit. It's the same principle. These are questions that he's been repeating over and over, just to guide you. Standard, platinum, and the differences in there. What's the probability that a randomly selected account will be 31 to 60 days overdue? So 31 to 60, you get the total, which is 198 over 661. Okay, what's the probability that the randomly selected gold card account is 61 to 90? So where they're meeting gold and 61 to 90. So 49, but what total are we looking at? The total, the grand total, because this is intersection. Determine whether the events are independent. This is what I'm about to teach you now. Please, these questions reoccur. My students in my class always do my homework and they get back to me. So if you don't do them, that's up to you. I mark immediately. All right. So now we're going to something interesting. I only have 20 minutes. At 20 hours, I'll be meeting the BIDs only, the beginners. So at this point, I'll ask for any questions. We only have.
Sorry, is it just me or volume is a bit low? I don't know. I'm asking for the other students.
Am I clear?
You're clear on this end.
Yeah, clear, but they're just a bit low. Okay, maybe let me just try and leave and join again.
All right, now we're going to what is called conditional probability. Conditional probability would be given a probability like probability of A is 0.2. Probability of B is 0.3. Probability of A given B is given by 0.5. So you'll be asked, number one, find the probability of A intersection B. So whenever you're given a conditional probability, expand it first. A given B, the bottom guy goes down here, and we intersect the letters A intersection B. So we now substitute what we have. A given B, this is 0.5. The intersection of A and B, we don't know. And the probability of B is 0.3. Then you cross multiply. So 1 times the intersection, we get A intersection B. And 0.5 times 0.3, we get 0.15. That is how we find the intersection of A and B. Intersection has 5 formulas. You need to know which formula to use. So whenever you're given a conditional probability, you're just multiplying this guy, it kisses the bottom guy. So A given B times B. If there was B given A times A. Is that clear? So we now go to the union set. The formula for the union set is the most faithful formula, like I said. So A union B is gonna be the probability of A plus the probability of B minus the intersection of A and B. So our probability of A, we're already given as 0.2. Our probability of B, 0.3. Our intersection we just calculated now as 0.15. So when we calculate this, we're getting 0.35. So what does that mean? When your intersection is wrong, it will affect your union set formula. So A plus probability of B minus the intersection. In the event that you're not given this conditional probability, to get the intersection, just multiply A and B directly. Because to intersect is to multiply. Now, suppose it was reciprocated. How do we find this formula? This bottom guy goes down here. Then we're going to intersect A intersection what? B. We usually prefer to start with the alphabet, which comes earlier. We've already calculated our A intersection B as 0.15. And our A is what? 0.2. When we divide this, what do we get? This in there.
0.75.
0.75. Then we know that our A is 0.2. So what does this mean? Our A complement will be what? The remainder from 100%. 1 minus 0.2, which is 0.8. If our B was 0.3, what is the complement of B?
0.7.
0.7. Now, the examiner will always often ask you to determine whether the events A and B are independent. What makes you independent? If your decisions as A are not affected by the decisions of B. So meaning probability of A given B still remains as A. Regardless of whatever letter is down there, whether we put R, Z, it still remains A. Or if you're given probability of B given A, for this to be independent, it must be equal to what? The top guy, which is B. That's a condition for independence. So step 1, we need to state the condition. Step 2, we need to compare the figures. Our A given B is given as 0.5, and our A is given as 0.2. Are they the same? No. So this is not independent. As simple as that, 2 marks. I repeat, for you to know that A and B are independent, probability of A given B must be equal to A, or B given A must be equal to B. That is the procedure. You need to state the condition. If you want B given A to be equal to B, but just from calculating what B given A was 0.75 and our B is 0.3, neither of these are the same. So 0.75 is also not equal to what? 3. So we're going to say these events are not independent. There are only 2 conditions. There's independence and mutually exclusive. To be mutually exclusive is to have nothing in common. If you're dating somebody and you discover that they have nothing in common with you, start using statistical terms to say you and I are what? Are mutually exclusive. It means the intersection is what? Is 0. So step 1, state the condition. Step 2, compare the figures. We found our intersection as 0.15. Is it the same as 0? No. So what does that mean? A and B are what? Not mutually exclusive. So it is very imperative you understand these terminologies. You cannot guess at this stage. You need to understand the principles. You cannot guess at this stage. You need to understand the principles. So takes me to what is called Theorem 2. But before I go to Theorem 2, Gloria has a question to ask. Yes, Gloria.
Sorry, a quick one. Just kindly state the principle for mutually exclusive. I missed that.
For mutually exclusive, events should have 0 intersection. So A intersection B must be equal to 0. That is a rule. Otherwise, if you don't get an answer equal to 0, it means they're not mutually exclusive. So events are mutually exclusive if and only if their intersection is 0. An applied perspective is which events can never occur at the same time. You can't be a boy and a girl at the same time, or investment decisions in the company. You can't build a bridge and buy a boat at the same time. You'll be cost what? You'll be ineffective. Things that should never occur at the same time. That's what mutually exclusive means. So the intersection must be equal to 0 or empty set.
Okay, thank you.
Is that elaborate?
Yes, please. Thank you.
All right. Gloria, you need to get an A in this course. Vanessa, in this, what's this new BID? Cambole. Each intake, there are not less than 10 A's from my class. So I need to start picking you from the first day. All right. So we are now moving at the condition which is called Theorem 2. Theorem 2 is all about intersecting and getting the common letter. A intersection B plus A intersection B. If the subject is B, the complement must be on the other letter. In short, we're picking the common letter here. Which letter is common? A, not B. Which common is that? Common here is B. So even without giving you the subject, if I have D intersection A plus B intersection D, when I add these two, what letter should I have at this end? Probability of what? The common letter, which is D. All right. Common letter, which is D. Now, question 1. If only SNAT was closed. All right. Which is the only one I gave the solutions to the last part. So now let's do this question together. I only have 10 minutes before I end my session. Consider an insurer that offers 2 types of policies, the home and the car insurance. 87% of all customers have home insurance, whereas 97% of all customers have car insurance policy. Every customer has at least one of the 2 policies. So let's summarize the data. We're going to let home insurance be what? H. And what letter can be for car insurance? Always have a key. It's important. All right. Let's C be what? The car insurance. So what have we been told in here? The probability that one person will have a home insurance is 87%. So probability of H is 0.87. And the probability of car is what? 0.96, which is 96%. At this point, are we all together?
Yes.
Yes.
Then we are told that each customer has at least one of the policies. So when we combine H union C, we're going to get 1. The first question, what is the probability that a customer does not have a car insurance? What are they asking for?
A complement C.
Yes, the complement of C. Good. Does not have car insurance. So the complement of C. How do you find the complement of C?
It's 1 minus itself.
1 minus C itself. Good. So this is 1 minus 0. What?
96.
To get 0. What?
0.4.
So meaning what's the probability that 1 does not have a home insurance? It's 1 minus home. It's a complement of home. Altogether, we're now applying the concepts that I've been talking about. Part 2, what's the probability that 1 has a car insurance and a home insurance? What are they asking for?
Intersection.
The intersection.
Yeah. Section.
of car intersection H. All right. Formula number 2, which we had. All right. Car intersection H is equal to the probability of what? C plus probability of what? H
Home
minus the union. C union H. Here, if we had we union, would have put intersection there. Because we have intersection, why are we using this formula? Because we've been given the union set formula already. The probability of C is 0.96. Probability of H is 0.87. And the probability of the union is 1. So what are we getting when we add this plus that minus 1?
Zero 0.83.
Pardon?
0.83.
0.83. So why are we using union? Because the word and means what? Intersection. So they're asking for C intersection H. I was happy most of you got this answer correct. In fact, all of you got this answer correct. 1, 2, 3. It's just one person who got the last part correct. All right, part 3. What's the probability that he has a home insurance given that he has a car insurance? What's the probability that he has a home insurance given that he has a car insurance? What are they asking for?
Sorry, read the question again.
Part number 3. What is the probability that the customer has a home insurance given that he has a car insurance? What are they asking for?
Conditional.
Conditional probability of what?
Having home insurance.
Home insurance.
Given car insurance.
The slash means given car insurance. So we're going to have home intersection car over a bit of having a car insurance. Are we agreeable on this?
Yes.
What is our home intersection car? We just calculated 0.83. All right. So here we put 0.83. And what is the probability of a car insurance?
0.9.
0.96. So what do we get? 0. What?
0.86.
0.86. Okay. .86. Now, this is where I had issues. probability that he does not have what? Car insurance, given that he has home insurance. So probability he does not have what? A car insurance, so car complement, given that he has a what? Home insurance. So here, what goes down there? It's a probability of H. Then on top,
It's car complement intersection H.
whenever you have a complement, this is theorem what? Theorem 2. If the complement is on C, meaning the subject should have been what? H. So meaning H is equal to what? C intersection H plus C intersection what? H. But the complement is on what letter?
C.
If the subject is H, the complement is on the other letter C. So we have the probability of H as 0. What? 0.87. Here we don't know this one here. It is C complement intersection H. But the probability of the intersection of H and C we have is 0.83. Now, Papata, every time you have an intersection and there's a complement, this is theorem 2. So just expand it as it is. You guys could later punch, intersect, complement, and there. This guy here, you need to know that if the complement is on C, meaning the subject should have been H. If the complement is on H, the subject should have been C. Just expand it. Or you try both of them and see which one fits. Then what will happen? 0.8 what? 7 minus 0.83 will give us 0. What?
0.5, 0.4, sorry.
Which is the C complement intersection H. So here we're going to put 0.04. The probability of H is 0. What?
Eight, seven.
So what do we get here?
Zero point 0.046.
0.046. All right.
Mm.
So let's start, see where you need to make your corrections. All right. I have to rest my case here. Unless there are any questions, speak now or forever hold it. So part C is asking, what is the probability that a customer does not have car insurance, given that he has a home insurance? So the direct notation of that one is probability does not have car insurance. So C complement, given that he has home insurance, given that he has home insurance. So this is a notation. That's the first thing you need to know. So the guy who goes down here is probability of H. Then on top, we have C complement intersection H. At this point, are we together?
Yes.
Yes.
So because of this guy, there's only theorem 2. Okay, you can try either of them. So probability of C and probability of H to see which one is relevant. So for these two, you're just adding 2 intersections. This probability of C intersection H plus probability of C intersection H. Also this one, probability of C intersection H plus probability of C intersection H. So if C is subject to a formula, the complement is on H. If H is subject to a formula, the complement is on C. So of these two, we need to find one which has this missing figure. So definitely it's not this one here. We're going to use this one here, the second part of theorem 2. Is that clear? So we don't have C complement intersection H, that's what we're looking for. But we know that the probability of H is 0.87. And the probability of C intersection H, we just calculated as 0.83.
83.
So when you take this guy this side, it is 0.87 minus 0.83, which will give you 0.04. So this comes here, 0.04. And the probability of H we already have is 0.96. 0.87. So when you divide these two, 0.04 and 0.87, we're going to get 0.046. Is that clear?
Yes, thank you.
You're welcome.